To improve customer privacy, commercial speech products are reducing their need for human transcription of customer data. But since the distribution of word and topics drift over time, language models trained on transcriptions of old customer data will become stale. So let's consider the following scenario. On a certain date, we cease transcribing of customer data and throw away previous transcripts. This is the best case scenario for customer privacy. We are allowed to keep models that we have trained on old customer data up to that day. Now let's say 1 year has passed. Because of temporal drift, our language models don't have new vocabulary terms or updated distributions. How can we best update our language models? We have access to automatically transcribe speech, but none of it is available for human transcription, so that rules out approaches like active learning. A natural idea is to fine-tune the historical LM on automatically transcribed speech. However, prior work has shown that the language model training is more sensitive to transcription errors than other approaches like acoustic model training. We also cannot use adaptation methods like data concatenation or pre-training since we no longer have the historical transcripts. In this paper, we propose a novel extension of knowledge distillation that learns from two teachers. The adjunct, trained from recent but machine-generated transcripts, and the emeritus, trained from human-generated but out-of-date transcripts. We'll use these two teachers to jointly train a single student model. As detailed in our paper, we found the optimal approach to be to first fine-tune the adjunct model from the emeritus model, and then jointly train the student model through knowledge distillation. This outperformed alternative methods such as fine-tuning or training from scratch. Our corpus was a collection of anonymized voice assistant recordings where we simulated transcription ceasing after December 2017, and our test data was January 2019. All of our models use the same 10,000 word piece vocabulary and were unidirectional LSTMs. Our baseline is the emeritus model only, and our upper bound is assuming that we can continue to transcribe data and we can concatenate old and new human transcripts through fall of 2018. We report word error recovery, that is the fraction of the total possible gain between the emeritus and our upper bound concatenation. If we just use the adjunct model trained on recent machine transcripts, the model degrades in performance, but improves significantly for the head distribution, indicating that the model is better memorizing what it already knows. Our baseline adaptation approach is knowledge distillation, where we use the emeritus model as the teacher and the automatically transcribed data as the fine-tuning data for the student. We see improvements in overall word error rate, but a degradation in the tail. Finally, our method gives a gain over knowledge distillation without degrading tail word error rate. Please see our paper for more details.